Hello everyone, I'm Wouter and I would like to talk today about computing program syllabi, or more specifically, what do they reveal about non-technical expectations of undergraduate students. So I would like to present the results of our paper today, but before we delve into the details, let's first meet industry veterans Kelly and Sandra. Kelly and Sandra are experts in the industry, they are software engineers, and they actually expect graduates to be technically really good and really proficient, as usual, but also more and more industry veterans expect our graduates to be well equipped with professional skills or so-called soft skills, and that's the focus of the research I would like to talk about today. So on the one hand, we have the industry veterans like Kelly and Sandra, and on the other hand, we have the academic teachers like Jeff here. Jeff tries to integrate the expectations of the industry veterans into the already overfull computing curriculum. And today I would like to help Jeff out a bit, hopefully with the results of our paper, so he can make informed decisions and get inspired by his colleagues. So actually what we would like to answer today is which non-technical skills are currently being taught in undergraduate computing science courses. We don't really know yet. There's little known about what skills are being taught and why. And once we've answered that, we can also answer the question, what types of non-technical courses are there actually out there? So how do we get about that? Well, I'm just going to skip ahead on the related work here because we're short on time. Let's go right into the method. So what did we actually do? We manually curated a list, a really big list. So we gathered lots of data from learning outcomes in computing syllabi. So how did we go around that? Well, first we tried to search all European universities and try to see which one we could gather the data from. Then we tried to find relevant computing courses. And last, we tried to extract skills from the learning outcomes. So, which universities did we actually include? Well, it was based on the QS World University Rankings, and we filtered on Europe. More details are in the paper, why we did that and how we did that. And we tried to aim for about 30% coverage rate. So, for instance, if we didn't find any data from a certain university, we tried to skip ahead and take the next one in the country to really maintain that ratio. Okay, so which courses are we looking for? Well, we're looking for courses that teach non-technical skills. So things like algorithms 1 or 2 or mathematics. And so we're not really interested into those. Not to say that they don't teach anything non-technical related, but the focus is for us on this study is on the other courses. So how did we go around that? On the institution website, we try to search for an undergraduate computing page, which usually contains a list of all the courses. Then we try to search that list for likely non-technical courses, and if there was no link found, we try to perform a Google search. If there was still nothing found, we excluded that. More on why or how is written down in the paper. So which skills are we going to extract? Well, once we found the detail page of a certain course we were interested in, we try to manually tag each skill found in the learning outcomes. For instance, on the slide here, we have something like blah, blah, blah. Students are required to work in teams to promote communication skills. So they're talking about teamwork. So teamwork is tagged. And they're talking about communication skills. So oral communication is tagged. So this is all happening manually. There's no interpretation of the text involved by a script or an AI. Of course, this also was cross-validated by the second author. Right, so let's dive into details, into the details of the results. The most interesting thing is the result page we have right here. We developed an online tool to make the results visible and to help the academic teacher Jeff out and to be able to connect with all academic teachers who already are doing something like that. So for instance, when I click on France, you can see that the tool zooms in and he shows us how much courses we identified within the country of France. So for instance, for 47% of the courses are project-based, 22% are communication-based, and so forth. And then you can also see that this filter is actually filtering on the selected country. Let's see for Belgium what we can see. Belgium has another division. So let's first click on results. This category is the most interesting right here. Why? Because it summarizes everything we found. We try to group all the found and identified skills in 8 different categories, like you can see right here. And you can sort on the percentage to see how many project-based skills, how many humanities-based skills, and so forth we identified. When you click on one of those, you can see the identified skill for the course group art or creativity. Of course, creativity is identified, and when we, for instance, look at project, we see teamwork, to be able to set and keep timelines, presentation skills, written communication, oral communication, and so forth. So these are all identified within, let's see, for instance, let's try to here. Cardiff University in UK, for instance, has a Bachelor of Computer Science, and there was a course called Group Project. When we click on the course itself, we get to the detail page of the course, and you can see the URL where we scrape the data from, all the identified skills, which are right here, and the learning outcomes. These learning outcomes, we didn't touch those, we just copied them over, and then we tried to identify the skills based on the text and the learning outcomes. Of course, not all universities offer a page like this in English, so we had to do some translations or translate it ourselves. I either did it myself when I could translate it, or we did it using Google Translate. So I can go back to the main page if I want to do. And as you can see, this is a list of all the universities which were included. The intended coverage and details about that is also available. So this is an interactive website, so you can browse through this, search by skill, for instance. Let's see if I want to do something like team, and you can see that teamwork is present, or creativity. Creativity occurred about 4.5% of the times. That's not a lot. That's not a lot at all. You can see that most of the identified skills are teamwork, ethics, written communication, presentation skills, oral communication, and so forth, which is not a shocker, of course. Right. So limitations, more on that in the paper itself. So what can we do about what can we do with this tool we made? Well, Jeff, for instance, can use the experience of his colleagues, which we have well, somehow put together in one big online tool. If he wants to integrate both the technical components and the non-technical components, which are requirements from the industry veterans, into the curriculum, then we can use the tool to find, for instance, something about creativity and how the other universities within Europe did something like that. So that's the main goal, or the main purpose, and we really hope this will be of use for the computer science education community. And well, we're really excited to hear from you guys what you think about it, and hopefully it will be of some use. So please let us know. For us, our future work is trying to zoom in on a few underrepresented important skills, like I thought about creativity. Why is it underrepresented, and what can we do about that? Right. Thank you very much.